Okay, so next we're going to go ahead and finish off chapter 3. There's only one last section. I like to talk about this separately just because it's too much to kind of get in our minds when we're still wrapping our mind around distributions and independence and all that. This last thing in chapter 3 is called Simpson's paradox. This is a more advanced idea. I've never seen this actually on the AP test, but it is in the textbook, and it's kind of an interesting topic. So it just shows how seemingly innocuous use of data can still lead to incorrect conclusions. And this is based on some actual data that occurred back in the 1970s. So the idea behind this is that you can have something called a lurking variable. That's a variable that's affecting the data that is not being taken into account in a study. And what causes this thing called Simpson's paradox is a combination of having a lurking variable and then having unequal sized groups being combined in a certain way in a single data set. So the only way to really understand this is to see it in an example. So this is an example from the textbook, which is actually based on real data. So this data was the data which was the foundation for a lawsuit that was brought against the University of California, Berkeley back in 1973. In 1973, the admission records for that year showed that they had two categorical variables here. They had men and women that applied, and then they had two categories for what happened. There was admitted and not admitted. So the data is that of the 2,165 men who applied, 47% were admitted, and of the 849 women who applied that year, only 31% were admitted. Right? So shame on UC Berkeley for admitting more men than women, right? And in fact, when that statistic, just in that form, was released to the public, there was a group of women that filed a lawsuit against UC Berkeley for gender discrimination back in 1973. Okay, so statisticians looked at this data further as part of the defense, and what they said is, we need to look at these because the people that applied, they didn't apply in the same way to the college. The college consists of different majors. And so they divided the majors into categories that seemed to behave similarly. So, there was one major, and for the purposes of our illustration here, there are 4 categories of majors. For example, maybe they were business, engineering, fine arts, and education, or something like that, okay? And so when they subdivided this, they looked at how these applicants were split out into what majors they applied to. In major number 1, 825 men applied, and 511 were accepted, which was 62%. And in that major, 107 women applied, and 89 were accepted, which was 83%. So actually in that particular major, a higher percentage of women were accepted than men. And then in the second category of major, 560 men applied, 352 were accepted, which was 63% acceptance rate, and 27 women applied, 17 of which were accepted, which was also 63%. So that means that in this major, an equal percentage of men and women were accepted. In major 3, the numbers turned out, you can look at these, that 34% of the men were accepted in this major and 35% of the women were accepted, so a slightly higher percentage of women were accepted. And in major category 4, 6% of the men and 7% of the women were accepted, and so more women were accepted. So when they looked at it on a major by major level, in all majors, either the same percentage or a higher percentage of women were admitted to the college than the men. And yet, when these were collapsed into just men and women, there was a lower percentage of women overall that were selected. So pause the video for a second and think for a second, see if you can see why this is happening. In the class, we would have a discussion about this at this point. All right, so here's the problem. If you look at where the men and women applied, right, most of the men tended to apply like 825 and 560 to these first 2 majors, and fewer men applied to these majors. But it was the reverse for women. Most of the women applied to these 2 majors. And these 2 bottom majors happen to have lower overall acceptance rates. This major only accepted 35%, this only accepted 7%, right? So the reason why this happened was that men just happened to apply to the easier to get into majors, and women happened to apply to the hard to get into majors. So even though there was no gender discrimination going on within the majors, the data appeared to be suggesting that there was gender discrimination. Right, so the lurking variable in this case is the college major. Not taking this into account by combining unequal sized subgroups produces an erroneous conclusion. So the first person that suggested this was a researcher named Simpson. So this is named Simpson's paradox. It's kind of an interesting thing. Now, if you want to know a little bit more about that or see some other examples and that really talk about this in a lot more detail, there's a really great YouTube video. I'm just going to leave it on the screen here for a sec. You can pause the video and then go look at it if you want. And I'll try to include a link on it on the class page for that. I don't know if I'll do that, but you can get this link here. And then, yeah, actually I will do that so it's easy to get to. So you can watch this little video to really see it in detail. It's a fascinating topic. All right, so that concludes chapter 3. At this point, the class is going to revert to working in groups on working through the required practice packet and the extra credit practice packet, and then this will culminate in a quiz. All right, that's it for chapter 3.